Okay, this is section 4.3. We're going to be discussing solving quadratic expressions by factoring. This tends to be a rather complicated topic for students because every factoring problem can be different. Okay, so you're really going to want to reference what is in this box. This will help you kind of categorize which type of factoring problem you're up against and sort of help you through the technique you would want to use to factor it. Okay, so here's one important thing worth noting at the beginning. Before you factor, okay, before you go about factoring, there's a few things that you need to do at the very beginning, okay, and that is make sure that all of your terms are in descending order. That means you have the largest exponent first, and then they gradually get less and less until you're down to just a constant, if that exists. And then you want to make sure that the lead coefficient, the number all the way in front, once it's in descending order, needs to be positive. So, for example, if your problem was, say, 4x minus 20x squared, to put this in descending order, you would put the negative 20x squared first and the 4x second. To take care of the fact that the lead coefficient should be positive, that means we want this 20 to be positive, you would simply factor out a negative 1 all the way out in front, and that would essentially flip the signs on these. This is how the problem would look at the beginning. Okay, these are the things that you need to do on the front end before you categorize then which type of factoring problem you're up against here. Okay. So what we're going to do here is we're going to gradually, this list gradually gets more and more complicated in terms of what you have to do in order to factor. So we're going to start with the most basic type of factoring problem first, and that is the type of problem where all you can do is factor out a GCF, and then after you have removed the GCF, what remains cannot be factored any further. Okay. Also, definitely worth noting that all factoring problems, you should begin by checking for a GCF. Okay, you want to do that as well on the front end. Okay, so let's look at example 1A. We can see in example 1A, it looks like this problem here is already in descending order. It looks like the lead coefficient is already positive. So I'm going to go ahead and start by checking for a greatest common factor. That would be a number and or a variable that both of these terms appear to have in common. It looks like both 30 and 5 share a 5, and both x squared and x share an x. So we're going to say our GCF for this problem is a 5x. Okay, that's what we're going to factor out in front. Okay, when you factor out things like a GCF, what you are actually doing is you are going to divide both of those terms by the GCF, and that helps you figure out what you should leave behind in the parentheses here. Okay, you do need to make sure that you show that GCF set out in front, but as I simplify each of these terms here, this fraction 30 divided by 5 would reduce to a 6, and x squared divided by x would reduce to an x. Okay, over here in this term, a 5x divided by 5x, we know anything divided by itself is the number 1. This is how the expression would look factored. Please keep in mind that when you factor something, in theory, you should be able to remultiply this 5x, distribute it back together, and get right back to the original problem, the 30x squared plus 5x. Okay, this is the most simplest type of factoring problem. We removed the GCF. There is nothing more we can do with a 6x plus 1 to get that to factor further. Okay. The second type of factoring problem is called a difference of two squares. Okay. The way that a difference of two squares looks once you factor it is a plus b, a minus b. Okay. Now, in order for it to be a difference of two squares, I want to break down these words here. Difference means the original problem has to have a subtraction sign in it. If this were addition, then it would not classify as a difference of two squares. Okay, secondly, there has to be two terms. So if you see more than two terms, if it's a trinomial, it's not going to fit into this category. And then thirdly, the two terms have to be perfect squares, okay? To be a perfect square, that means your exponents both would have to be even. For this problem, or in this section here, they would be 2's. And any numbers that would fall in front of these would have to be perfect squares as well. Things like 9, 16, 25, numbers that you could take the square root of. Okay, once you've identified that it is in fact a difference of two squares, what you do is you take the square root of your first term. Okay. To factor this, you're going to make two sets of parentheses, put an addition sign in the middle of one, a subtraction sign in the middle of the other, and when you take the square root of the first term, and here I'm generically just writing this, the square root of a squared, the answer to that, which is a, goes in the first position of each set of parentheses. Okay, then you would take the square root of your second term, that would be the square root of b squared, which is b, and you put that in the second position. And that is how you factor a difference of two squares. So let's look down here at example B. Let's first just make sure that this is qualifying as a difference of two squares. The other thing that you do not want to overlook is you want to make sure that it is in descending order, that the lead coefficient is positive, and that there isn't a GCF that you could remove all the way at the beginning of this problem. There is not a number between 25 and 36 that could be factored out. So we are good to go to check and see, does this qualify as a difference of two squares? Well, first of all, it meets the difference criteria because there is subtraction. It meets the 2 criteria because there are 2 terms. And it does look like it is meeting the squares criteria because I see that these numbers 25 and 36 are both perfect squares. And my variable has an even exponent, a 2, which means it's also a perfect square. Okay, so when I've identified that this is a difference of two squares, what I'm going to do next is I'm going to create 2 sets of parentheses. I'll put addition in the middle of one, subtraction in the middle of the other. You will then proceed to take the square root of the very first term, both the number and the variable. The square root of 25x squared is 5x. You will put that answer at the beginning of each set of parentheses because this was your first term. That answer then goes in the first spot of each set of parentheses. Okay, you will then take the square root of the second term. Okay, square root of 36 is 6, and you will put that answer, because it was the second term, in the second spot of each set of parentheses, and that is then considered factored. Okay. Let's go ahead and look at example C before we move on to the trinomials here. Okay, in example C, this might be difficult to see here, but there are actually 2 terms here. This is all one term because everything's multiplied together, and then this is your second term. It's separated by this subtraction sign right here. Okay. So I'm going to go ahead and first say, well, is there a GCF that I technically could factor out of both of these terms? And as I look at these 2 terms, I notice that what they have in common is they both have an x minus y quantity cubed. So I'm going to go ahead and say that is the GCF. That's what I'm going to factor out in front. Okay, I'm going to go ahead and factor, I'm going to slide this down a little bit. I'm going to pull that out in front. Okay, remember, once you've identified a GCF, in your head, what you're doing is you're dividing each of the terms by the GCF, and then you're going to look at each of these fractions to kind of cancel to determine then what you would leave behind in the parentheses. For our first fraction, it looks like the x minus y cubes cancel, leaving you with x squared, and in the second fraction, same thing, leaving you with a minus y squared. Okay, that is us factoring out and checking for a GCF first. The second thing we want to do then is look at what you have left behind, this x squared minus y squared, and ask yourself, does that fit into one of these other 3 categories? Well, it's not 3 or 4 because there's not 3 terms there. It's not a trinomial. Let's see if it's a difference of 2 squares. Difference means subtraction. 2 means 2 terms. Squares means the exponents on the variables need to be even, which they are, which means this part right here in blue, I technically could break that down and factor that even further. So I'm going to keep my GCF out in front, x minus y quantity cubed. And then I'm going to put two more sets of parentheses, one with a plus, one with a minus, and I'm going to take the square root of my first term. Square root of x squared, that's an x, so I'll put x there and there. Then I'm going to take the square root of the second term. Square root of y squared is y. I'll put y there and there. Okay, you could leave the answer like this, or if you look closely, you'll notice here is one quantity of x minus y. Over here, I have three quantities x minus y. I could technically combine those together and say I have four of the quantity x minus y, and then just one quantity x plus y, and that would be a much more simplified answer here for this. Okay, let's try the same thing with example A here. Again, we're going to examine, here's one term, here's another term, and we're going to say, first of all, let's do that checking for a GCF, see if we notice that these two terms have anything in common. And it certainly looks like they both have this quantity of 5x minus 6y to the fourth power in common. Okay, so we're going to pull that out of both terms. Again, kind of in your head, you're going to picture dividing each of these by the quantity 5x minus 6y to the fourth. That's going to cancel out of the first fraction, leaving behind 25x squared. Cancel out of the second fraction, leaving behind 36y squared. Minus 36y squared. Okay, now just because you factor out a GCF doesn't necessarily mean you're done. You always need to examine the portion that you've left behind and ask yourself, can you factor that part further? Okay, again, this is not a trinomial because there are not three terms here, but let's see if it fits as a difference of two squares. Difference, subtraction, two terms, squares. Well, the variables have even exponents and the numbers are perfect squares. So I think that would be able to be factored further. So you're going to copy down the GCF, then you're going to draw two more sets of parentheses and put a plus in the middle of one and a minus in the middle of the other. Okay, we're then going to take the square root of the first term, which would be 5x, put that in the first position, then take the square root of the second term, that's 6y, we'll put that in the second position. And then let's just examine here. Here we have 4 of the 5x minus y's, but here's an extra one. So let's combine all those together as saying that we have 5 of those, and then we have this one extra 5x plus 6y. That would be a good answer there. Okay. All right, let's look at example B here. In example B, it looks like this is in descending order. It looks like the lead coefficient is positive. I'm going to start then by checking for a GCF. Looks like 20 and 15 would both have a 5 in common, and x squared and x would have an x in common. So I'm going to be dividing both of these by my GCF of 5x. Okay, divide by 5x, divide by 5x. Looks like what we're leaving behind is a 4x plus 3. Now this problem, as you look at what you have left behind in the parentheses, 4x plus 3 is not a difference of two squares. It's not meeting the difference criteria, and it's not meeting the squares criteria. Although 4 is a perfect square, 3 is not. The exponent on the x is not even. So this is as far as I can go. This is this first type of problem where you have factored out a GCF, and now what remains, you cannot factor that any further. Okay, you can look at example C here and kind of follow how I did that one there for you. We're going to go ahead and move on now to these two trinomial problems. Let's start with number 3, okay? A trinomial where your lead coefficient is a 1, okay? A trinomial where the lead coefficient is a 1. This is a little bit easier than when the trinomial's lead coefficient is not a 1. So let's go ahead and start with example D. You can see it's in descending order. There is no GCF, nothing we could factor out of all three of these. And you'll notice that the lead coefficient is a 1. Okay, now the directions here say to start by making an X chart. And I'm going to have you place right up here in the notes a big X, and in the top of the X, I want you to put A times C, and in the bottom of the X, I want you to put a B, okay? Now, if you have a trinomial and the lead coefficient is a 1, off to the side, you're going to make a big X. You're going to place in the top of that X the A times C value. Now, in this problem, the A is the 1, the B is the 16, and the C is 64. So if I did A times C, that would be 1 times 64, or just 64. And then the B value is the 16. That's what goes in the bottom of the X puzzle. When you factor these trinomials that have lead coefficients of 1, you will give yourself 2 sets of parentheses, and you will start by putting an X at the beginning of each set of parentheses. But we don't know if these are supposed to be pluses or minuses just yet. We have to solve this X puzzle. The way we go about solving this is we try to think of 2 numbers that multiply to be 64, but add to be 8. Okay, and there's only one possible solution to that. This particular solution is 8 and 8. So you would fill in positive 8, and that is how that would look factored. Okay, let's try another one. Here's a trinomial again. We can see the lead coefficient is a 1, so I'm going to set this up 2 sets of parentheses. I can put an X here and an X here, but then I'm going to make an X puzzle or X chart here to help me solve for what numbers I should be filling into the latter half of these parentheses. Okay, A times C, that would be 1 times 20, or 20. The B value is 9. I'm looking for 2 numbers that are going to multiply to be 20, but they have to add to be 9. Those 2 numbers would be 4 and 5. It doesn't matter which one you place where, but they are both positive, so you should put a plus in front of the 4 and a plus in front of the 5. Okay. Now, the most difficult type of factoring problem is the kind when it's a trinomial, but unfortunately, the lead coefficient is not a 1. Okay, these are the most difficult. You'll notice the instructions here tell you what you're going to do is you're going to factor by grouping. Okay, what I do not want you to do is I do not want you to use a strategy called guess and check, where you just blindly guess and check until you've stumbled on the right answer, okay? I want you to write up here in the box next to number 4, which is factoring by grouping. I want you to draw 4 blank lines and put an addition symbol in between each blank. That will serve as kind of a visual reminder of how you need to start these problems when the trinomial is not a 1. I'm sorry, when the lead coefficient of your trinomial is not a 1. Okay, you do always want to make sure it's in descending order, and you do always want to check for a GCF. I don't think that all 3 of these numbers have a factor in common. What you're going to do to start this then is you're going to draw those 4 blank lines with an addition symbol in between each blank, and I want you to put the first term on the very first blank, and then I want you to put the last term on the last blank. Okay, now what we're going to do for the middle 2 blanks is we're going to split this middle term, negative 12x. Okay, you're going to make an X puzzle just like we did on the other trinomial problems. You're going to put in the top of the X puzzle A times C, which for this problem would be 36, and then you're going to put the B value in the bottom of the X puzzle. Okay, again, you're trying to think, what are 2 numbers that if I multiply them, they're going to multiply to be 36, but if I were to add those numbers, they're going to add to be negative 12. Okay, you can spend some time kind of trying to think through that would be, but the only combination that would work is negative 6 and negative 6. Okay, so you're going to put a negative 6 on one blank, but make sure you put an X after it, and then a negative 6 on the other blank with an X after it as well. Okay. Now, the reason this process is called factoring by grouping is because once you get all 4 blanks filled in, you're going to then group the first 2 terms together. You're going to group the last 2 terms together, but make sure that you leave that addition symbol in between those middle parentheses. Okay. What you will now do is you will now look for a GCF that you could remove from just the first set of parentheses. So what a 4x squared and a negative 6x have in common is a 2x. So you're going to remove a 2x from a 4x squared minus 6. And again, just think of that process of you're dividing each of these by 2x. Okay. And then in the second set of parentheses, you're going to say, well, what is a GCF that I could remove from a negative 6x plus 9? Now, here's the catch. whatever you're going to remove from the second set of parentheses, the goal is what you leave behind needs to match what you have left behind in the first set of parentheses. So when I first look at 6 and 9, I think I should pull a 3 out. But if I look closer, I notice this 6 is negative, but what I left behind here was a positive 2x. That tells me I should be factoring out a negative 3, not a positive 3. So I'm going to, in my head, divide each of these by negative 3, and that's going to make this a positive 2x minus 3. See how this quantity and that quantity now match. Now, remember these problems up here where we had quantities that were the GCFs that we factored out? That's now what we're going to do here, okay? You can see that here is one factor, or one term. Here's another term. Those two terms have a 2x minus 3 in common. So again, when you divide or take out a GCF, you divide by what you're factoring out. So I'm going to divide by 2x minus 3. And what I would leave behind from the first term, this is just a coincidence, by the way, is a 2x. And what you leave behind in the second term is a minus 3. So your answer is 2x minus 3 times 2x minus 3, or you could write it, since there are two of them, as a 2x minus 3 squared. Okay. All right, let's try another one of those. Let's go ahead and flip back here to example A. We'll just take a look at this one. This will be a good place kind of for us to stop, except we're just going to, I think this will be a good place for us to stop. We'll try one more of these here. Okay, so as you look at example 3A on the back, you'll notice that there is no GCF that we could pull out of 6, 23, and 20. This does feel like it's a trinomial, but the lead coefficient is not a 1. So I'm going to draw the 4 blank lines. This is the work and the process that you need to show when you do these. Okay. First blank, I put the entire first term. Last blank, I put the entire last term. And off to the side, I'm going to make an X puzzle. I'm filling into the top of the X puzzle A times C, which is 120. I'm filling into the bottom of the X puzzle the B value, negative 23. Now, the bigger these numbers are, the longer it's going to take you to come up with what the solution is to this X puzzle. Okay, we need two numbers that are going to multiply to be 120, but they have to add to be negative 23. Here's a tip that if you are getting stuck trying to come up with the two numbers, especially when A times C is a big number, here's what I would encourage you to do. I would encourage you to make a factor tree and continue to break down your factors until you are left with just prime numbers, okay? So I'm doing this very quickly here, but I can see that the number 120 breaks down, if I reorder these, into 3 2s and 2 5s. Okay, this gives you a really good place to kind of play with different combinations of numbers that are going to multiply to be 120. Here's an example. You could group together these two 2s and say, okay, 4 times, and then I'm going to group together that 2 and those 2 5s, which I think 2 times 5 times 5 would be 50. Oh, that doesn't make sense. Did I do that right? 2, 5. Oh my goodness. No, I'm sorry. I messed this up right here. 20. Oh no, that's right. I think we're okay here. So I have messed something up. 120. Oh my goodness. I'm so sorry. Okay, you probably caught this way back here. I'm going to fix my mistake here. I didn't factor 120 right at the very beginning. That should factor into maybe 12 times. You can come up with any two numbers. I messed up my original factor tree here. Okay. All right, so 120, sorry about that, is going to break down into 3 2s, 1 3, and 1 5. Okay, this is what it breaks down into. Okay. Now, if I were to lump together these two 2s into a 4, and then 2 times 3 times 5, that's into a 30. Here's one possible combination of two numbers that are going to multiply to be 120, but they're going to add to be negative 23. Okay, I don't think that these would actually add to be negative 23, so this isn't the right combination. Okay, so what you would do then is you would go ahead and come back and try to think of, okay, what's another combination of numbers we could go with? Now look at this one. If I group these three 2's together, 2 times 2 times 2, that's 8. And I group this 3 and 5 together, look at this, that's 15. 8 times 15 is 120. If I made those both negative, they'd still multiply to be 120, but look at what they would add to be. They would add to be negative 23. That's the combination I'm looking for. It doesn't matter which one you put where, but right after the number, since there's y's in this, put a y next to it, okay? All right, so now we're going to, once the blanks are filled in, we're going to group together the first two terms and the last two terms, and you're going to remove a GCF from the first set of parentheses. Looks like we should remove a 2y from a 6y squared minus 8y. Okay, if we remove a 2y, I'm going to divide both of these by 2y. Okay. That leaves me with a 3y minus 4. Now remember the goal here, what you remove from this second set of parentheses, you want to make sure that what you're leaving behind will match this 3y minus 4. So I can tell a GCF would be a 5, but I want to make sure that I'm factoring out a negative 5, so that when I divide both of these by negative 5, it's going to make this 3y minus 4, and now those quantities match. Okay, so we're almost there. 3y minus 4 is the GCF. You're going to divide each of these by 3y minus 4, and that leaves you with 2y minus 5. There we have it factored. Okay, that is where we will stop for these notes.